right, this is from lesson 15-2. This is where you need to be able to multiply and divide. The angle turns through 1/5 of a circle. So we know a whole circle is 360 degrees. To find 1/5 of that, you multiply it by 1/5. This means you get 1 times 360 over 5, which means you end up with an improper fraction that looks like this. To do this, we have to divide. I'm going to do a partial quotient. I put my divisor there and my dividend here. Well, I know 5 times 7 is 35. So if I do 5 times 70, I get 350. And I have 10 left over. I bring that over here. 10 divided by 5. Well, I know 5 times 2 is 10, so it's 2. I subtract, I've got no remainder. My partial quotients are 70 and 2, so my answer is 72. 72 degrees is 1/5 of a circle. All right, sometimes we get asked about numbers that are not a unit fraction. It doesn't always have to have 1 at the top, but it's the same thing. 3/8 times 360 degrees. So I multiply 3 times 360 over 8. I know some of us were saying we kind of forgot that multiplication, 3 times 360. I really like, where can I do this where there's enough space? I really like the area model, 3 times 360. Well, the 3 in 360 is worth 300, and the 60 is worth 6. Well, the 6 is worth 60. 3 times 3 is 9. 3 times 30 is 90. 3 times 300 is 900. 3 times 6 is 18, so 3 times 60 is 10 times greater, 180. I've got my two partial products, 900 plus 180, and I add them. I get 1080 over 8. This is an improper fraction, so I have to do partial quotients. I really need to get like a tripod to hold my phone for this. All right, here. So I use my partial quotients. 1080 divided by 8. All right, well, I know I can multiply 100 times 8 to get 800, and I would have 280 left over. So I bring that over here. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24. So if I use 8 times 30, I would get 240 and have 40 left over. And I know that 8 times 5 is 40. I have no remainder. I add my partial quotients and I get 135 degrees. 3/8 of a circle is 135 degrees, which makes sense because I see this nice obtuse angle. All right, looking at these, use geometric terms to describe what is shown. We've already recorded these in class, but we have obtuse angle, HOS, which is this whole thing. Then we have two rays. We have ray OH and ray OS. Now those rays go from here on forever. We also have line segments, line segment OH, which is only from O to H. It stops right there. And line segment OS. These are slightly different, but you need to know the difference. This is only line segment BD, which would be written like this. All right, here we've got ray XY. That's from here on forever. And then we also have line segment XY, which is just the space between here and there. Here I've got right angle PTS from here to there. Then we also have two rays. I've got ray TS starting from here going that way, and ray TP. And then I also have my line segments TS, which is from here to there and no further, and line segment TP from here to there and no further. That is it.